Hi everyone, welcome back. So this is our second lecture for current electricity. So last lecture we understood the relationship between EMF, PD and loss. Okay, and today we are going to solve MCQs numericals on it. But before we do that, I want to do a very important topic since it's our first lecture where we are going to solve numericals together. Okay. So first we will do an introduction as to how to solve MCQs. Okay, and then we will go into the actual numericals. Okay, so let's begin with the NEET exam pattern as an example. Okay, the same whatever we are going to discuss, the same applies to JEE mains as well. Okay, and even MHT CET. But I'm just taking an example for NEET. So what's the paper pattern? So there are 45 MCQs in physics. Okay, 45 in chem and bio also, but let's just talk about physics for right now. The total time is 3 hours, but for physics you can count say 1 hour. Okay, so how long does it take to read one question? Okay, if I ask all of you, what would be your answer? Now, talking to several students over the years, okay, I have always got a response of about 15 seconds. Okay, one question it will take about 15 seconds. Let's say that is 1/4 of a minute. Okay, and the second question I would like to ask you is how many times do you read a given question, especially in a numerical of physics? Okay, so again, the common response I get people say is about 2 to 3 times, right? At least two, very often three. So that gives me an average of let's say 2.5. Okay, the average of 2 and 3 is 2.5. So again, each question is taking 1/4 of a minute. There are 45 questions. I am reading each question 2.5 times. So how much time are you going to spend reading? Okay, so it's 45 questions, 1/4 of a minute, 2.5 times gives me approximately about 28 minutes. Okay, so for 28 minutes you are simply reading out of 1 hour. Okay, so you now have left 32 minutes remaining. And what happens in these 32 minutes? After reading a question, people actually they go into some kind of meditation mode. They just start looking here and there, wondering what to do. They start, they just thinking something. Then finally, after a few minutes, maybe they start writing. Okay, and again, this goes on for every question, and ultimately at the end of the exam, or maybe when the score comes, this is what the result is. I don't want to scare you, but you can please talk to any 12th standard student or any student who has gone through the NEET or the JEE mains or the MHT CET exam. Okay, you are going to hear what I'm telling you. Okay, people are really short of time. So what's happening here? Okay, so this is what I always tell my students. Giving an entrance exam is like playing a game, and if you don't know how to play the game, obviously you're not going to score. Okay, you're not going to make any score. So the idea here is about speed. Okay, if you are playing a T20 match, there are only 20 overs. You can't play with the same style, using the same skills as you would in a test match, which is for 5 days. Okay, you can't do that, right? So that's like a comparison between board exam and any kind of entrance exam where MCQs are there. So what I want to do is I want to teach you today some new skills which I want you to practice henceforward. Okay, is just basic common sense that I'm going to talk about, right? If you read a newspaper, right, all of you must have read a newspaper. Do you read it 2 times? Do you read it 3 times? No, there is some problem here, okay, in your reading style. So again, I want you to practice this while solving any numerical. You can even apply this to chemistry as well, because in NEET exam chemistry some of the MCQs will be numericals. Okay, and even for JEE mains, right, those who are studying mathematics, you can try this out even there. Okay, for any kind of numerical, this is what I want you to practice. Okay, please practice it for each and every question that you are solving. Okay, so what is it? First of all, don't read the entire question. People read multiple times because their first reading goes in understanding, is this the question from my favorite chapter, or is this the question from a chapter which I hate? Okay, so these kind of, please don't have these kind of biases, because your chapter which you are, which you know very thoroughly, your favorite chapter, whatever difficult MCQ comes for that question, for that particular chapter, and the chapter which you left for option thinking, oh, this is too tough, I can't solve it, what if a very simple easy question is there on based on that chapter? Okay, so please don't have any kind of such biases. Don't try to figure out what chapter it is. Don't read the whole question. Okay, so what I want you to do is read a few words only, maybe 3, 4, 5 words at a time, and immediately, without looking here and there, without closing your eyes and thinking hard what to do, okay, immediately do the following. Okay, this is not some rocket science, it's very simple plain logic how to read. I'm teaching you. So first thing is, as soon as you read a few words, you may be able to immediately write a data, some number. Okay, the mass of a person is 10 kg, okay, or a mass of an object is say 10 kg. So write there m is equal to 10 kilos. Why? So that when you are solving the question, when you read the question and after that you are trying to solve it, you need the value of the mass m. You don't have to read it again to figure out, oh, what was it, let me go again and check it out. No, write it down. Okay, you will have a pencil with you, you will have some space in the entrance, any entrance exam, you will have some rough work space given. So just write it there, don't think the moment you read it. Or the second thing, which if you are not able to write any number, okay, any data, the second thing which you may be able to do is draw a diagram. A ray of light, say for example, all of you have done in 10th standard. Ray of light is incident at 30 degrees onto the surface of glass, and it bends and it goes here, there, whatever. So draw a diagram. Why are you thinking? Okay, there's nothing much to think about, because ultimately after thinking, okay, you will draw a diagram anyways. And if you can't write a number and can't draw a diagram, most probably you will be able to write an equation. Okay, like for example, I tell you age of person A is 10 years more than B. Okay, so I can just write it as A is equal to B plus 10. 10 years more, so plus 10, then whom? Then B. So this was just a simple example for an equation. Okay, so just do this data diagram equation for a few words that you read. Okay, and then suppose you read 5 words, you did this. Now what? Very simple. Just keep on doing this. Repeat it again. Read the next few words. Again do data diagram equation. Again the next few words. Again do data or diagram or equation. Keep on doing this till you reach the end of the question. If you follow this, by the time you finish reading the question, okay, the solution may be, trust me, it may be half ready already, how to solve. Okay, so please do this. Again, I'm not telling you to do it quickly, okay, because you saw the time, it's only about 1 hour that you have in the NEET exam. Okay, and the same, the number of questions are less, but the time is the same even in JEE mains. So that's why what I want you to do is practice this. Okay, I'm not telling you to do this data diagram equation very quickly right away. No, eventually you will gain speed. Okay, but first just slowly do this and try to achieve this, not reading any question more than once. Basically you have to be focused while reading. Okay, so second thing that I want to tell you is there are certain types of MCQs. If you are solving all the standard entrance books that are available in the market, okay, there are publications like Errorless, also called as Universal Self Scorer. Okay, there is Cengage, there is Pradeep, H.C. Verma. Okay, Arihant publication author, is D.C. Pandey. So like that, there are several good publications available in the market. You bring all the book, okay, and if you do a survey of all the MCQs, let's say we are solving 3 books, okay, 3 books total together would give me in physics subject roughly around 20,000 MCQs. See, if you spread out all these 20,000 MCQs and try to categorize them into certain types, okay, trust me, it is very shocking. You will notice that there are only about 11 types of MCQs. All these 20,000 or even more MCQs can be categorized into 11 types. Okay, all 11 of them we will cover it eventually, but for today, right now, okay, I want you to understand one very simple, basic, most common, I would say, type of MCQ is substitution. Okay, substitution is the most common type of MCQ. So again, I give this example of a football, and this example is valid not just for substitution, it is valid for all the types of MCQs that you are going to do. All these 11 types, this example is valid. Okay, so again, I ask my students, if you want to play football, there are two teams, okay, they have gathered on the field and they want to play football. What is the most important thing that is needed, without which you cannot play this game? Okay, so some people say you need a strategy, you need, good athletes, you need practice. Okay, but you see, you understand, with everything, with a good strategy, with the best of players, everybody is on the field, the stadium is full of spectators, but what do you still need to play this game? Very simple, you need a football. Okay, if you don't have a football and everything else is there, what are you going to do? So this is what happens with the students in the exam. Okay, so what I mean here is, in this game of NEET or JEE Mains or MSTCT, okay, whichever entrance exam you are giving, in this game, the most important thing, especially your football, right, to play this game, in physics especially, is the formula. Okay, if you don't have the formula, you can't play this game. It's very simple. All formulae have to be on the tip of your tongue. So again, the formula that we are going to use, based on what we understood in the first lecture, right, about EMF loss and PD, is that EMF plus or minus loss is equal to PD. Okay, again, just to a quick recap, EMF is the voltage that is printed on the label of the cell. There is always some loss. Why? Because inside, within the cell, there is a flow of current from low to high, and whenever there is low to high flow, there is always a loss of energy. Okay, and PD stands for potential difference, okay, which is the actual voltage that appears across the cell. So most of the times, especially the MCQs that we are going to solve right now in 11th standard, it's going to be EMF minus loss is PD. Why is that? Why EMF minus loss? Okay, the reason is because the cell is always in use, always the current is flowing, right, most of the time. But in 12th standard, we will see some few examples where we will have EMF plus loss, and that will happen when the cell is being recharged. Okay, so we'll not worry about the recharging case right now. Right, for now we will just say EMF minus loss is PD. Okay, so please, once we start, I'm going to take up a few examples. I want you to pause wherever you need to copy or write down anything. Okay, so just pause the video and write down, note down something. Just have a pen and a book on your notebook, and once you're done copying, you can play. Okay, click on play again. And the other thing I want to tell you is just a simple color notation that we are going to follow, because we are going to have voltage, current and resistance. So blue is for voltage. Any number you see anywhere on the slide, if it is blue, it's voltage. Okay, if it's red, it's current, it's green for resistance. Okay, so just keep this in mind. Okay, and with that, let's begin. And in the link in the description below, you can see I have given you the classwork, the numericals that I'm solving right now on the PowerPoint. Okay, they are there in a PDF file. You can just click it and maybe take a printout and use it if you want. Okay, there is also a link for two homeworks, one for log and one for the MCQs on EMF loss and PD. Okay, so after the end you can do the homework, but right now please you can use the link for the classwork. Okay, so let's begin. So the first question is, okay, the internal resistance of a cell of EMF 2 volts is 0.1 ohms. Okay, so stop here. We have read quite a lot in the question. there is no need to move ahead. This is what I told you by data, diagram and equation. Okay, so I've already got some information here. So what can I do about this information? Two things. I can just maybe write, say, E equal to 2 volts and small r is 0.1 ohms. Or better is, I told you, just immediately do either of the three, right? Instead of data, you can here in this case draw a diagram. So let's say there is a cell whose EMF is being told to me it is 2 volts. Okay, there is an internal resistance of this cell which is 0.1 ohms. So just draw it. Okay, and especially in the chapter current electricity, in all the MCQs you will notice that I would say maybe around 50% of the times they give a diagram, and half of the times they don't give a diagram. So it will become quite easy to understand if you draw a diagram. Okay, so draw a circuit diagram, especially this chapter is known for that. Draw a circuit diagram. So there is 2 volts EMF and 0.1 ohm internal resistance. Okay, fine. Let's continue reading now the question ahead. They are saying it is connected to a resistor of 0.9 ohms. Okay, so that means there is an external resistance whose value is 0.9 ohms and it is connected, right? So let's just draw the connecting wires. Okay, fine. Then the voltage across the cell will be. So finally what they are asking me is voltage across the cell. They are not asking what is the voltage printed on the label. What is printed on the label? In fact, we know already, it's the EMF, it is 2 volts. So what are they asking here? They are asking the PD. Okay, so we will start using our formula PD. Yeah, we know that, right? I have to do EMF minus loss. But if I have to find out the loss, the first thing that I need to do, right, is find out the current. So you can see in the circuit, current is going to flow from where? Okay, so I'm going to use this Ohm's law, which says I is equal to V by R, and I'm using the suffix T. RT stands for total resistance. So since there are two resistances, I need to figure out what is the total resistance. So let's see how is the current flowing. So it starts from the positive of the cell, right? A 2 volt cell goes through the external resistance of 0.9 ohms. Okay, so this I is going through 0.9 ohms, and this same I will then come out from 0.9 ohm and go into 0.1 ohms. So can I now say the 0.9 ohms and the 0.1 ohms, they are in series. So what can I say about my total resistance? It's going to be 0.9 plus 0.1. Why are they in series? Because the same current is flowing. Okay, so please keep in mind, series means same current flowing through two resistors, then we call them in series. Okay, so again let's put the numbers. The voltage value is 2 volts, okay, in blue, so please note the colors again. Okay, so 2 volts is the blue is our voltage, and the total resistance RT I just found out, it is 0.9 plus 0.1, it is 1 ohm. So 2 divided by 1 gives me how much current in red? It's going to be 2 amperes. Okay, fine. So now I'll use my formula. EMF minus loss, right, is going to give me the PD, and that's what I want to find out. PD is equal to EMF minus loss. Okay, and the loss can be written as a loss is within the internal resistance. Okay, and the loss of voltage it is, so voltage is current into resistance, so I will say I into R, but which R? It's not the capital R, it is the small r. So let's just plug in the numbers. So the EMF in blue is 2 minus I value in current, we just found out it is 2 amperes. Okay, and what about the resistance, right? We saw the resistance, it is not the entire resistance here. I just want to find out the loss. Okay, so which is, so I'm not going to use this 0.9 as well as this 0.1. Okay, I want the loss only within this 0.1, so I'm going to use 0.1 here for the small r value. Okay, so it's 2 amperes I into 0.1 ohms. Okay, so this gives me the voltage of 0.2 volts. So 2 is the EMF. Okay, so the EMF is 2. The loss within the internal resistance is 0.2. So what is the answer then? 2 minus 0.2. Obviously it's very simple. It is 1.8 volts is the PD. Okay, so again going back to the theory, you can now notice that this 2 has split. Right, the 2 voltage has split. I am getting 1.8 volts across the external resistance, right? So this external resistance can represent, say, if I put my cell in a, let's say, a remote control. Okay, so the remote control resistance, I can call it as 0.9 ohms, and within the cell there is some loss here. So that 0.2 volts which I found out is getting lost within the cell. Okay, so that's the idea here. So 1.8 volts. Okay, it's a very simple. Again, it's a substitution MCQ. You can't do anything if you don't have the football. Okay, you can't play football without a football. Okay, let's take the second question. So again, please note, you can pause and go back, just copy, write down wherever needed. Okay, battery of EMF 12 volts and internal resistance 3 ohms. Okay, so let's say there is a battery. It's a combination of cells, so I can just draw one cell. Okay, we need not draw multiple cells here, although they are calling it as a battery. I can draw a cell. So the cell battery voltage is 12 volts, internal resistance is 3 ohms. Fine. So voltage in blue, resistance in green again. It is connected to a resistor. Okay, fine. There is an external resistor. What is its value? No information given. So let me just call it as capital R, the load resistance here. Okay, fine. So it is connected. So we'll complete the circuit. If the current in the circuit, you see the previous question, we had to find out the current. Now here they are giving us the current. Okay, fine. So I know the current is going to flow in the clockwise from the positive of the cell to the negative of the cell. So this current they are telling me is 0.5 amperes in red. Okay, very nice. Calculate that external resistance. Okay, calculate the resistance of the resistor and the terminal voltage of the battery when the circuit is closed. So we need to find out this R, external resistance R, and terminal voltage of the battery. What does this mean? Terminal voltage. Okay, that means the voltage across the cell. Terminals means the positive and the negative terminal. So what is the voltage across the cell? That's what I have to find out. So basically I have to find out PD. Okay, so this is not an MCQ. This is just a question. The previous one, the first question, and this second question, these two questions are from our physics textbook of 11th standard. Okay, so the first one had options. It was an MCQ. This one is not an MCQ. Fine, we can still solve it. We know we have our football, right? So again, it's PD is EMF minus loss. So again, I'm going to say EMF minus the loss within the internal resistance. So I will say the voltage is going to be I into R, but which R? It is going to be the small r value, not the capital R value. Okay, fine. So the EMF is again in blue 12 volts, the current in red is 0.5 amperes, and what about the internal resistance? It is 3 ohms. So if I multiply 0.5 into 3, I get 1.5 volts. So out of 12, 1.5 volts is what is lost within the cell. So then what is the PD then? Okay, so 12 minus 1.5 is very simple, 10.5 volts. Okay, so I've got the PD. Now using this PD, still one more information is still to be found out, right? It is the external resistance R. So how do we get that? So again, we will just simply use Ohm's law. So Ohm's law will tell me that resistance is voltage upon current. Okay, so now which voltage and which current? So current is very clear. I know the I value is 0.5 amperes through both of them. They are in series, capital R and small r. They are in series. So current value is fixed. It is 0.5. Now what about the voltage? Should I take it as 12? Or should I take it as 1.5? Or should I take it as 10.5? Okay. So obviously it's not going to be 12, right? Because 12 is what is the voltage printed on the label. I want to find out the PD across, or the resistance of this value, which is the external resistance, right? So then I must find out what is the voltage that this external resistance is getting. So you can now very clearly see this external resistance is going to get a voltage of 10.5 volts, because that is what is ultimately found across the cell. What is across the cell is going to be given to the external load. And this 1.5 is actually, nobody gets it. It is a loss, right? And 12, anyways, again, we are not going to get because it's the EMF. So EMF is not possible. The loss is not possible. It is this PD which is appearing across this external resistance R. So what am I going to substitute? I'm going to substitute 10.5, and I already know the current is 0.5. So if I just, multiply the numerator and the denominator by 2, okay, double of 10.5 will give me 21, and the double of 0.5 is 1. So 21 upon 1 is 21 ohms. Okay, so this is the second question. Again, please, you can pause here, before going to the next question if you want to copy down. Okay, let's take a third example here. So using a cell, a current of 0.9 amperes flows through 2 ohm resistor. Okay, so 0.9 in red, 2 in green, please note. So there is a cell. What is its EMF? Not given, so let's just call it as E. Okay, what is the internal resistance? Is it 2 ohms or is this 2 ohm the external resistance? Okay, so they did not, you see they are saying 0.9 ohm flowing through 2 ohm resistor. They did not use the word internal. So that means this 2 ohm is my external resistance. Okay, and what's the current flowing? So let's just draw the connecting wires. So the current we know is going to flow from the positive to the negative, and the current value is 0.9. Now you see I've kept a gap here because I still have to think, should I consider the internal resistance or not, because nothing is mentioned about it. Okay, fine, so let that gap be, we will think about it. Okay. Let's continue reading the question ahead. So again, so using the same cell, now I'm getting a current of 0.3 amperes. So the current value initially was 0.9, now it's becoming 0.3. And the resistor, which was 2 ohms, is 7 ohms. That means now I can clearly understand it's a second circuit. It's not the same circuit diagram. It's not the same component. The diagram is similar, okay, but it's a new external resistance with the same cell. It's using the same cell. Read the question. Using a cell, we get this and this. So it's the same cell. So the same EMF E. It's not E1, E2. Okay, it's the same EMF E. But now the external resistance is not 2 ohms, it is 7 ohms. The current through the circuit is not 0.9 amperes, it is 0.3 amperes. So then the question here is, what about small r? So if I continue reading ahead, I get the clear hint here. The question is, find out the internal resistance of the cell, right? And again, it's an MCQ. So if I want to find out the internal resistance of the cell, I must draw it first, right? So let's complete the circuit diagram. There is a small r. Now the EMF is the same, E1. I'm not going to write E1 or E2, I'm going to write E. What about the internal resistance? Should I write it as R1 and R2, or should I just keep it as R? So the answer is, again, it's the same cell. Okay, the internal resistance is the loss of, it is a representation of the loss of the chemical energy that was happening. We discussed this in the first lecture. So that loss of energy will depend on what kind of a cell it is, right? If it is Duracell, there will be a certain loss, right? A certain conversion of chemical energy into electrical energy. And if it is some other cell, it will be some other value of small r, right? So for a given cell, I can now assume that the internal resistance small r is a constant. Okay, fine. So now I have these two circuits and I have to find out what is the answer here. Is it 0.5 or 1 or 1.2 or 2? So what can we do here? So we have two unknowns, you can see now in the circuit diagram. Earlier there was only one circuit and one unknown, the first two questions. Now there are two circuits and you can see, therefore, because we have two unknowns, then hence we have two circuits. The two unknowns are the EMF. The EMF is unknown. The internal resistance is unknown. They are asking us the internal resistance, but you should understand the EMF is also unknown. So since we have two unknowns, we need two equations. And since we want two equations, we have been given two circuit diagrams. Okay. So again, I can just use Ohm's law. Okay. Ohm's law tells me that voltage is current into resistance. So I can say E is I into R total. So let's use this for the first circuit, the circuit on the left. So what is the current value? So we know the current in red is 0.9. Okay. What is the total resistance? Again, for both of them, you can agree that the current is flowing through the capital R as well as the small r. So they are in series. So what is the total resistance in the first circuit? I can say it is 2 plus R. 2 is a resistance, 2 in ohms, R, I don't know. So let's say R ohms. So 2 plus R in green is the total resistance. Okay, so let's just open up the brackets. If I open up the brackets, I'm going to get voltage. Okay, I'm finding out voltage. The LHS is a voltage. So this is, the E is a voltage. These two numbers have to be voltages. Okay. So what do we get? So we get 1.8 volts. 0.9 into 2 gives me 1.8. 0.9 into R gives me 0.9 R. Okay, fine. Now let us apply this same equation, because the EMF is the same, to the second circuit. So again E is equal to, okay, so I can just say continue with equal to sign and say, now the current value I, okay, so is the same E is equal to this, as well as E is equal to the new equation. Instead of 0.9, now I have 0.3. Okay. What about the external resistance? Instead of 2 plus R, I have 7 plus R. Again, let's open up the bracket. So 7 into 0.3, 7 3s are 21, so 0.3 will give me 2.1. And then 0.3 into R is 0.3 R. And again, these two are voltages. So if both of these are the same EMF E, then what can I do with these blue voltages on the left and the right? I can just equate them, they are equal. And then just rearrange the terms. So let's bring 0.3 R into the LHS, so it will become minus 0.3 R. And let's take this 1.8 on the RHS, so from plus here in the LHS, when it goes to the RHS it becomes minus 1.8. So further solving this, okay, we will get 0.9 minus 0.3 gives me 0.6 R, and 2.1 minus 1.8 gives me 0.3 volts. Okay, so if I divide the two, resistance 0.3 upon 0.6 is going to give me basically half ohms. Okay, so we have got the answer. The internal resistance of the cell is 0.5 ohms. Okay, so again, if you want, you can pause here to copy. Okay, so we are at the last example for the classwork today. So this is question number 4, and again this is now very similar to the previous question, question number 3. So I am using a cell and there is a current of 0.5 amperes, okay, which is flowing through again a 2 ohm resistor. So I will draw the same circuit diagram. There is a cell whose EMF I don't know, so I will say E. Okay, the external, they have not used the word internal, so we will have to consider it by default as the external resistance is 2 ohms. Okay, current is flowing, so we can use the wires and say current is flowing, and it is of 0.5 amperes. And now using the same cell, I am getting a 0.25 amperes of current flowing through another resistance of 5 ohms, not 2 ohms. So you see earlier it was 7 ohms, now it has changed to 5 ohms, right? And the current has become, instead of 0.3, it is now 0.25 amperes. So again, no information is given about the internal resistance. Okay, and see what are they asking this time. Their question is find the EMF of the cell. Okay, find the EMF of the cell. So if you have to find the EMF of the cell, should I consider the internal resistance? Yes or no? Because see, previously they were asking the internal resistance, so I drew it. But now if I just take this question by itself and not compare it with any other question, should I consider the internal resistance if this question suddenly pops up in the exam? Because you see, the exam, the questions will not be in a sequence, so they will not be chapter wise. Okay, they can be randomly from anywhere. So if this pops up and you are thinking, should I consider small r or not? So let's give it a thought. Okay, what's the voltage here? Because I know resistance, I know current, so I can find out the voltage across this external resistance. So voltage is Ohm's law, current into resistance. So I'll get 0.5 into 2. So 0.5 into 2 is how much? Right, 2 into half is basically 1 volt. If I don't assume any external resistance here, that means there is a 1 volt cell which is being given, that 1 volt is being given to my load. But if I look at this circuit, 5 into 0.25, which is 1 by 4. So 5 into 1 by 4, 5 by 4 will give me 1.25 volts. So in the first circuit, I am getting the EMF as 1 volt, and in the second circuit, which uses the same cell, I am getting an EMF of 1.25 volts. And obviously you have to understand here that there's something wrong. Why? Because the EMF is the voltage printed on the label of the cell, and the label of the cell is not going to change in the middle of the operation of the circuit, right? While using the cell, how can the EMF change? EMF is a constant quantity once the cell is manufactured. Okay, at the beginning, let's say at the beginning, because eventually as the cell is being used up, as the chemical energy reduces, the EMF also goes down. But if I have brand new cell, okay, I just got it from the shop, a brand new cell, and I'm using it, the EMF, I can consider it is a constant. So if the EMF is a constant, that means the discrepancy we are getting here between 1 volt and 1.25 volts is because of the internal resistance. Okay, so again we must consider the small r. Okay, so again we have to find out the EMF of the cell. Okay, so we know the formula, EMF or the voltage is current into resistance. So again let's apply it to the first circuit. So again the current value we know is 0.5 amperes. Okay, the resistance is 2 plus R. Okay, open up the brackets, 0.5 into 2 gives me 1 volt plus 0.5 R. Apply this same formula, I into RT. I'm just doing the same thing what I did in the previous question. Okay, the current value has now changed to 0.25 amperes. Okay, the total resistance now in the second circuit, not the first one, the second circuit is 5 plus R, they are in series. Open up the brackets, 0.25 into 5 gives me 1.25 plus 0.25 into R is 0.25 R. Both of these are the same EMF values. Okay, is the same E in both the circuits. So I can equate the two, again just rearrange the terms. Let's bring 0.25 from the RHS to the LHS, so it will become negative, minus 0.25. And let's take this 1 here, which is in the LHS, to the RHS, it will become minus 1. So what is 0.5 R minus 0.25 R is 0.25 R, and 1.25 minus 1 is 0.25. So again dividing the two numbers, I am going to get the internal resistance is 1 ohms, but that's not the answer. This 1 ohm, we got the value of small r. I want to find out the EMF. So can I substitute this small r where it was missing? Either here in the first equation or here in the second equation. Any one of the two you can substitute. So let's say I put it in the first equation. So what do I get? 2 plus 1. So what is 2 plus 1? The green number here. This green number, plug it in here. So 2 plus 1 is 3. What is 3 into half? What is half of 3? So answer is, it's going to be 0.5 plus 2 plus 1 into 2 plus 1 is going to be 1.5 volts. So that's my answer. But will I get a different answer if I substitute it here? Let's check it out. So the small r is again 1 ohm, put it here. So what is 5 plus 1? 5 plus 1 is 6. Okay, 6 into 0.25. Okay, 6 times 0.25 is 0.25 is nothing but 1 by 4, 1/4. So 6 by 4, 6 by 4 again divided by 2 will give me 3 by 2, which is nothing but the same 1.5 volts. Okay, so that's all for today. Please download the homework files. There are 2 PDF files. I've just given 3 MCQs for the homework from EMF loss PD and 3 for log. Okay, so please solve them, and you can ask me doubts on WhatsApp, or you can just email me, call me, okay, or WhatsApp. Okay, so that's all for today. See you next time.